Also, when it comes to generative AI, as you probably already know, the field moves so fast that oftentimes one of the key things that I want to highlight is that you actually don't need to go and build fancy generative AI products.
So how did you guys go about like thinking about metrics, like then validating the hypothesis, and then finally telling, okay, this is the model that's working well?
Quality has many dimensions when it comes to images. It can be aesthetics. Is it, aesthetically appealing? It can be relevance to the prompt. It can be correctness. It can be proportions.
Could you go into the details of the fundamentals of inference? What are you doing there?
In general, every AI model goes through this life cycle of training and inference, and a lot of folks think of it as a disjoint process that you're done with inference and you're starting training now, or you're done with training or starting inference. It's not as 0-1 as you would.
How does Instagram and Facebook work? Like when I think about Instagram, it's basically recommending new content to people. So how do people use models there?
The most common way you would use AI models in Instagram is the recommendation feeds. If you go to like watching your short form videos and you're scrolling.
Can you walk us through your journey in launching your Amazon's first AI generation solutions? How did it go? What was the go-to-market plan, the concept of the market that you had at that time?
Yes, it was. I think we started in late 2022, early 2023, and it was definitely a combination of working back to the customer and moving from the technology, right? Because you have to think of all these large companies. They want to be seen as industry leaders and innovators, especially in AI. So we had to balance the actual customer problem to solve with how do we ensure that we are innovating and at the forefront of technology. Also, when it comes to generative AI, as you probably already know, the field moves so fast that oftentimes the average user may not even know that there's this latest and greatest model or architecture or new adapter that's going to solve a problem for them. So it's very hard to work back from the customer from that perspective. It's more about how do we meet in the middle, right? Get the innovation and start prototyping, and then find the product intercept to ensure that we have the right balance of the customer problem and the solution there based on the latest innovation. So yes, we went through I'd say it was a lot of research and development in the beginning, right? Testing all these technologies, figuring out how they can be applied. And then we had an ideation phase to actually turn it into a solution for a customer problem. For Amazon, it was about lack of creatives. And when I say creatives, it's think of images used in advertisement today, right? That's an example of a creative at the highest level possible. As an Amazon seller, you may or may not have the skill set or resources to create your promotional content. Especially the small mom and pop shops, they probably can't hire a graphic designer, and they probably don't have the best graphic design skills to go full on with Photoshop. So we thought that was a great customer to focus on to solve their problem, so they can start promoting their products on Amazon more.
No, that is awesome, Anita. So I work for a food tech startup. I see the pain point for sure. Like especially when we talk to restaurants, they want to create like high quality images that can give a very good representation of the food items. But what ends up happening is they don't understand the lighting, they don't understand where to place, what to showcase in an image. And we have used generative AI to a certain extent to create like restaurant like food items, and we have also experimented using that, and we have seen a good success. But eventually, in order for us to like productionize it, that has always been a challenge for us, because when you like try to put those images, they might not be exactly representing the food products, or the restaurants might not be very keen to like use those images to sell their items and stuff. Can you also talk us through like how you went from this R&D approach of like generating these images eventually like working with the sellers to like get this to the market?
We did create a prototype to begin with, and we validated the early output that we were generating with actual sellers. One of the key things that I want to highlight is that you actually don't need to go and build fancy generative AI product to validate it, right? The proof of concept can literally be pull up Midjourney, for example, or even Canva and create something for a specific seller, for a specific product, using those tools and see if it resonates with them, if it solves their problem. And then you can start building the solution that is a one-click solution, an automated one that they can use themselves. And then from there on, we had multiple work streams in parallel. Of course, identifying the right models to go with, the training set, and the entire time the focus was on creating the best solution for the customer, reducing friction, and quality. Quality has many dimensions when it comes to images. It can be aesthetics. Is it, aesthetically appealing? It can be relevance to the prompt. It can be correctness. It can be proportions of, because you're generating something for an actual product, right? Like a bottle of shampoo, for example. How are the proportions in the final image of the product versus the rest of the contextual image itself? So those were some of the things that we focused on before launch.
So essentially, you're saying that initially you had this goal of, okay, we want to be the technology leader, and then you went back trying to figure out what would be the best problem we can solve from the customer side. That's when you started, but essentially you said you did some R&D, tried to validate the proof of concept. Is that right? And you validated that kind of using multiple different tools to see if that was the right fit or no. And once you knew it was right, then you started actually building the product. Is that right?
I can't really go into the details of how we built it because of
Okay.
Amazon policy. But that being said, I will tell you how I would do it today based on my learnings. And that is, I would not build any generative AI product or model before I validate a very early artifact based on publicly available free tools. That's what I would try to do. Even if it's manually, so forget generative AI, go and manually cut and paste certain things together, focused on image generation today, and see if they address the problem that your customer has. And then after that, start thinking about the solution and how you're going to build that optimally.
Yeah, absolutely. And I think one takeaway from this would be that you don't need to build the complete suite, the product here, right? You just go back with already, because there are like so many tools out there. You can validate the idea and see if it's the right idea. Is it solving the pain point of the customers? And if you think that is pretty valid, then you can go back and actually build the product, right, for the users.
That's correct, especially because generative AI is so expensive to run. We talked about computational needs, right? And you want to minimize your costs before you know you have a solution that's going to address the customer pain point.
Yep. Actually, another thing, right? So I'm going to talk primarily from a product manager standpoint. So when we try to like launch these 0 to 1 products, or even like any new feature enhancements that we try to launch, we think about the metrics. AI is in a very, I would say, like weird space right now, where you might have to think about metrics on the AI models, like how is it generating, are these actually good images, and then finally the business metrics, whether it's generating value to the customer or not. So how did you guys go about like thinking about metrics, like then validating the hypothesis, and then finally telling, okay, this is the model that's working well?
I'd say and I like your differentiation between AI metrics and business value metrics. Yes, for AI metrics, especially when you are in a 0 to 1 space, you kind of have to make them up as you go, right? And then you iterate to improve them moving forward. For example, I talked about quality. There was no benchmark for image quality when we started, especially not, in the company. So how do you address that? You put a stake in the ground and say, today, this is the output that is our baseline. And that's the quality. And from that, you start measuring your improvements moving forward. And that way, you create a benchmark, basically. For AI, as things have evolved, more metrics around security, for example, around responsible AI, whether the output is safe for work, whether it showcases some artifacts that should not be there. For example, fragmented watermarks, right? That should not be there. And those are the type of things that you need to ensure when you build an AI-based product. And then, of course, on the business side, I'd say there are more traditional metrics. You do want to look at customer adoption, engagement, especially if it's something like an advertising or promotional product. The engagement is going to be on the viewer side, right? You're running the ad. What's the engagement like for the AI generated ads versus the non-AI generated ads? Is there a difference there? And those are the things that I would say would be good metrics. And of course, retention. Hopefully your customers keep coming back to use your tool if it's a good one.
So Anita, I know previously when we were building some of these products, right, I think the biggest concern was accuracy for us, right? Quality, as you said, for images, for text generation, it was accuracy, and it was not easy to measure some of this. So a lot of time it was initially manual, then we came up with some automated ways to do that. But what do you say, right? Like, are there enough methods to measure accuracy for some of the outputs that come out of these models now, or are they still evolving?
It depends how you define accuracy. So to me, accuracy is akin to prompt relevance. Is the output faithful to the prompt itself? That's what I would think of it. And that is one of the dimensions of what I think of overall quality. Look, at what you think as quality and what you think of high accuracy is different than what I think of that, right? And it is because we don't have a set framework in the industry to say this is how we will define high accuracy, 90% accuracy, for example, or 90% quality. So I think it's important to understand the limitations of the technology that you go with and try to educate your customers as well about these limitations. When you provide a one-click option for them to generate promotional image for their products, it's not going to be 100% of the time of the same quality and accuracy as if a graphic designer that maybe you pay hundreds to thousands of dollars would do and deliver in a much longer time.
That's right. And I think specifically you mentioned accuracy is relevance to the prompt, right? Because a lot of times what I have seen and what others, some of my peers have also seen is that the prompting is not right? People don't prompt the right way to get the output. So sometimes there's a lot of education where you have to give the users how to write your prompts and all to get better outputs rather than just giving some half-baked prompts, right? Essentially. So yeah,
Here's my suggestion for that to solve that problem. And it may not be a popular opinion, but I will say it anyway. Don't give all the controls to your customer, because 90% of them or more are not AI experts and they're not prompt engineers, and you don't want them to be prompt engineers. You want them to just be the users of your product and make that product frictionless. So all that being said, is there are ways to abstract the prompting so that you still take some input from the customer for the actual description of the final image, but you handle it through your workflow in different ways, where in the back you generate the description how you think is best. So you create a solution that 90% of the time, or depending on how you define it, is going to generate relevant, highly aesthetic images based on certain criteria that you employ. And by actually running aesthetic models, I believe Stable Diffusion has one that you can implement. So you can do that. You still give the customer, the feeling that they have some input, but you actually take the heavy lift from them and create the prompts yourself. And you can do that by employing text generation models to generate those prompts.
Let's maybe deep dive into some of the fundamentals of inference. So before I go into that, I will just give people a little more context on what inference and training are. So essentially, models go through training and inference, and training is something where you start training the models on large sets of data. And once the training is done, when you put it into production, right, whenever anybody gives it a prompt, whatever it does in the background uses its knowledge, it's inference, right? So if I'm not wrong, could you go into the details of the fundamentals of inference? What are you doing there, and also throw some light of how could this be scaled, and what are some products that you are building to help it more efficient?
Yeah, so in general, every AI model goes through this life cycle of training and inference. And a lot of folks think of it as a disjoint process, that you're done with inference and you're starting training now, or you're done with training or starting inference. It's not as 0-1 as you would think. Let me explain a bit. So training is essentially, as you said, you feed model labeled data, so structured data, and understand and make it figure out how exactly the data is related, what is the correlation of properties, so it can make sense of that data. Inference is when I'm giving you unlabeled, unstructured data, and the model has to give me an output. For LLMs, inference would look like generating new content. So I'm giving you a text, asking you to write a story. You look at your previous training data, which is the bunch of stories that the model has been fed, and it writes a new story in that tone, in that sort of structure, and in that thinking as a writer, right? So that's inference for an LLM. For a most common predictive model, it is just predicting your next line of text, or you're writing an email, it's predicting that. That's inference for a model. But these two things are not very separate. So if I have to use an analogy, I have a golden retriever, I have a dog, right? You train a dog, you try to train them how to play fetch by throwing a ball. They bring the ball back, give it a treat, and that's how you train them how to fetch a ball. That is just a training piece. Inference is when I'm asking him to fetch something else, fetch something from his toy box, fetch a frisbee. That's inference for him. He's not doing the same exercise he was trained to do. He's extending that logic to other areas, other objects, other spaces, problem spaces.
So if I can add, so essentially he's generalizing the knowledge which he has gained through the training that was done, and using it to other applications, which is completely slightly different than what it is. So if you were to correlate that with something what we do on regular basis, right? So imagine I'm preparing for a math exam. So I'm going through so much of notes, information, trying to figure out how to do certain things, how to learn certain things, and also I'll maybe doing some practice questions on how to solve it using that knowledge. But when I go to the exam, I might not get the same question, but I'm trying to apply that knowledge into a different question and trying to solve that. So that's basically inference.
It is, but if I was to go one step further in analogy, it is not just you're doing a math exam. It could be a specialized version of math. It could be I'm doing arithmetic only, or geometry only, or differential calculus only. So I learned on the base set, but I'm not extending that technology out further areas. So that's when I said the general assumption is training and inference are very binary. Even after you train a model, it's not done. Through the life cycle of the model, and this is one of the things we at Meta do called distributed inference. So because you've trained the model once, it's been published. So it is ready for consumption for products like Instagram, Facebook. But you always are getting new data. So let's say this entire month I trained the model, I put it in published state, and Instagram is using it. But we realize there's a new trend where people are watching a lot of dog videos. So you have to retrain part of the model to just recommend more dog videos to certain users. So you take a part of the model, retrain it, and update it in the inference pipeline. So now the model knows something new. Because that's always a challenge with AI models, where they learn something, and if they don't keep constantly updating, they become stale.
Oh, that's very interesting here. So in general, I could think about text and see how a model interprets the new text and then generates whatever is the outcome that it gives. How does Instagram and Facebook work? When I think about Instagram, it's basically recommending new content to people. So how do people use models there?
The most common way you would use AI models in Instagram is the recommendation feeds. If you go to watching your short form videos, you're scrolling, depending on how much time you spent on a video, how much of it you watched, and how quickly you swiped up, that would all be fed into a model to sort of make the decision or infer what exactly is the next kind of video you would like. Right now, that also includes like your likes, dislikes, all that stuff is taken into account. But as I said, the model has been previously trained on all your preferences or other users' preferences of what video is sort of hot. But there's a possibility that some things have changed and now everybody's watching videos of the Emmys or something else that happened recently in the world. So that part of the model will be updated so that when you keep swiping, you might come across some new content. So that's what we call snapshot update.
I want to ask like one quick, I want to make it as simple as possible, right? Let's take Sidhu, let's take me. So already Instagram understands both of us, and whenever I go to Instagram, it just gives me a feed. Let's say now I go and like a specific video or comment on a specific video. What I'm guessing is this new inputs are being fed to a model, and that model continually outputs saying that, hey, these are the new videos that you need to show to fun. Now, let's say you have a new model that you launched from Meta. Let's say I'm the PM for Instagram. Now I want to use this new model. I'll just replace your old model and start feeding the new data to it. Is that what you do?
Not 100%, because if you replace the entirety of the model, it has obviously forgotten what you liked in the past. So we update parts of a model.
So
That's
different.
why there is yes, it is a differential then.
Okay.
Because models are constantly learning, right? And if you have the entire model being replaced, you lose all the context that the model has learned over the time.
So I'm thinking, most of the time this goes hand in hand, right? So there is also always training that's going on, and
Yes.
there is also inference. And how frequently is this updated? Like, can you share that information? Is it like days or
As
weeks?
frequently as the product requires it, technically. The reason we have a single platform for inference across Meta, what is called IP Next, is because we do want to update models quickly so that our users don't fall into the stale sort of state. They don't see old content, things like that. So as the product requirements come in to us from Instagram or Facebook or WhatsApp or even Reels now, they will tell us how often they want the model to be updated. And based on that, it is the platform that makes a decision of how quickly to update these things. The challenge here that people don't realize is these parts are being updated in very small increments, so you do have to keep them in sync. So you have to make sure when you replace a part, it is still aware that there's a previously said, like you might have 10 parts to a model. I'm replacing only 2. It still has to communicate with the remaining 8 to make sure your content makes sense, and you don't see something that is absolutely out of the blue and you're like, why am I seeing this now?
Just for the audience to understand, right? What is differential inference?
We call it distributed inference, and it is the fact that a model individually is doing inference at a base layer, and then you have parts of the model, they're doing their own inference. So it's all contributing to that parent model. Think of it as a tree. So you have the base layer, and then you have that model divided into different parts, and each of the part has its own snapshot. Snapshot is basically its memory in time. So a model can be divided into like 3 or 4 parts. Each of those parts have a snapshot. There's a snapshot who's serving you inference. So distributed inference means a snapshot can serve you inference. It can aggregate all the inference together and serve it at the parent layer. So it is depending on what the user is looking for. If you just want to see videos in the same sort of theme or content, you keep scrolling, it is the parent who is doing inference. But if you, let's say you want like spice up the feed and you want to see something new, it might be a new snapshot that was just updated and it knows about, let's say, a recent event. So it will serve you that kind of video. So that's what distributed inference looks like for Instagram.